Hello, Craig Yambor here. Welcome to my in-depth analysis of the NSF Video Showcase item that I felt was most interesting to detail. It is Science Learning Through Engineering Design, or SLED. Okay, let's take a look at a couple important links. First is the NSF Video Showcase link to the SLED program, a 3-minute overview, great quick view. Next, you can find the website link for the program, which has tons of great content, including the actual activities. Now looking at the team contacts, first up is the principal investigator, Alyssa Panach. She's a professor of biomechanical engineering at Purdue University, and you can see her contact information there. You see some images of the other team members, but the team's actually quite extensive. So if you go to that team contacts link, you can find many team members' contact information and the role they played on the project. As for a summary, the SLED initiative is a partnership between Purdue University and several Indiana public schools to develop a classroom curriculum for grades 3 through 6. The curriculum is designed to drive investigation of scientific and mathematical principles through practical activities that require use of engineering design to develop and model integrated solutions to solve authentic, real-world problems. This cooperative effort between teachers, future teachers, and university researchers is providing curriculum activities that are mapped to the Indiana state standards. Additionally, the SLED initiative is helping to ensure teachers and future teachers are better prepared to present content that blends scientific principles with engineering processes. Also, the initiative pushes students to use inquiry skills and become invested in devising their real-world solutions. Finally, the SLED program is committed to gathering evidence of outcomes to help understand how teachers teach using design and how students learn through design-based activities. Related to STEM perspective, the SLED curriculum views the engineering development process as an avenue to better introduce scenarios involving math and science where students can be pushed to address real-world problems. After being provided some level of guidance and foundational instruction, the students can discover and explore math and science concepts while developing a solution to the identified problem. Further, while addressing the problem, students are introduced to engineering principles and processes to ensure their solutions are developed with rigor and implemented in a controlled manner. By targeting grades 3 through 6, the SLED initiative clearly has a focus on working to build and enhance early positive experiences with science, math, and engineering. As for a coherent set of standards, this multi-grade curriculum is mapped to Indiana state standards. Regarding teachers with high capacity to teach in their discipline, again, this program engages teachers in development, sharing, and cross-training of the activities included in its curriculum. This includes a summer institute, and a link here. As for a supportive system of assessment and accountability, each activity includes documented, suggested follow-up and assessment strategies. Finally, related to adequate instructional time, again, the documented activities have timing guidance. Regarding the inquiry continuum, each of SLED's individual activities for grades 3 through 6 may vary exactly how they fall on the continuum scale. And it's worth noting that most could be modified to fall slightly differently per your needs. But I've made some generalizations here as the activities show in the current pool on their site. First, related to how learners are engaged in scientifically oriented questions. All the activities I reviewed, the questions were teacher guided. Next, related to learners giving priority to evidence which allows them to develop and evaluate explanations that address scientifically oriented questions. Well, for the most part, the lower grade activities were teacher guided, and many of the upper grade activities were more learner self-directed, provided some room for them to make some decisions in this area. Next, looking at learners formulating explanations for evidence to address scientifically oriented questions. In this area, I saw it as a progression of levels of learner self-directed. Most of the activities had some level of learner self-directed, experience here, but of course, again, in the lower grades, it was minimal, and it seemed to ease up as it moved through the grades. Now looking at learners evaluating their explanations in light of alternative explanations, again, I saw a progressive level. Again, lower grades mostly were given a fair amount of guidance and pushed in the explanation section, where the upper grades activities provided a little more open opportunity for them to present and explain. Then, for learners communicate and justify their proposed explanations, again, a progressive level of change as you move through the different activities. Lower grades, more guidance; upper grades, more self-directed. Why SLED? Well, though I encountered several intriguing initiatives on the NSF Video Showcase, I selected the SLED program for my deep dive because it represented the most practical value for an educator, especially one in my current position. As I move into a more long-term assignment, I can easily see myself coming back to the SLED site and reviewing the 30+ and growing activities listed there. I can see myself leveraging these activities to enhance and grow my own classroom curriculum. While alignment to Indiana state standards is not a direct benefit to me, it shows that these activities are applicable in today's education environment. Finally, all the activities are practical, require nominal materials, and are potentially adaptable for a variety of situations.